Hello. I thought today I would take a look at how little we actually know. I know science is creating wonders, technology is producing awesome things, and yet, strangely, when you start to dig beneath the surface of all this technology, what we really know fundamentally is not much at all. And I'm going to refer to my notes here because otherwise I'll forget stuff. And there's probably more things that I've forgotten to write down in the first place anyway. But let's just think about what we don't know about everything. First of all, consciousness. How does it work? What is it? Is it real? Some philosophers even deny that it exists, which seems like a tautology to me somehow. Clearly I know what's going on. Well, I think I know what's going on, I suppose. What can I say? I experience the inputs from my senses as objects in a 3D world. Now, obviously this 3D world is a virtual reality created in my brain somewhere from electrical signals. But beyond that, not only do I have this virtual reality, the key thing about consciousness is that I know that I have a virtual reality. I mean, the camera that's looking at me has an image of me in a 2D form, okay, in its system. But it doesn't know that it's looking at me. It doesn't have consciousness, as far as I know. We think that the camera doesn't have consciousness. And even if we pointed the camera at a mirror so that it has a representation of itself inside itself, I think we can be fairly sure that it doesn't have consciousness. Or if it does, then everything is conscious. And it doesn't really answer the question of what consciousness is. How is it that things have qualia, as the philosophers say? They have qualities. Like, I don't merely know that a red object is red, or that this bluish mug is bluish. Okay. I experience it as bluish. It's not just some data point in a table somewhere with the bluish box ticked. It actually looks bluish, right? Or blue-greenish or something, whatever it is. I'd say blue. I like blue. But it doesn't need to look like that for me to know that it's blue. I could just have some table with a box ticked like a computer does. To say, what colour is the mug? Bluish, tick. We could have the specific frequencies of light ticked, or the average of the various ones on it. But no, we actually feel it in a way. And this is wholly mysterious. Now, neuroscientists will tell us that it comes down to activity in neurons in the brain. And when certain neurons are firing, or some combination of them, you experience something. A bad smell, a nice mug, a cup of tea, a sound, a thought. You don't just have them, you experience them. And we know, since Freud at least, that we have thoughts that we are not conscious of, and experiences that, if you like, not experiences, but activity in the brain that we are not conscious of. And we only become conscious at the end of the process when, pop, it comes into our awareness as a fully formed thought. And we even make up excuses for the things our subconscious want to do that we didn't think we wanted to do in the first place, but then we end up doing them anyway. Because guess who's not in control, right? The monkey is not in control of the elephant, ultimately, as I've said elsewhere. But this explanation by neuroscientists, although it's what we measure. We can measure the activity, and a person can tell us, oh, I was experiencing the colour blue then. It doesn't make sense, actually. First of all, these measurements are not that consistent. If you look at the data, sometimes this pattern of neurons is associated with the particular experience, and sometimes some other pattern of neurons seems to be associated. And typically, the ones that don't fit are considered to be erroneous. But the data sets are usually far too small to be statistically significant anyway. So this science is largely spurious as yet. But still, it's pretty obvious to any thinking person that consciousness does seem to have something to do with the brain. But how can it? Because the activity of a neuron, or a whole bunch of neurons, 1 trillion neurons or 1,000 of them or whatever that's needed to experience blue, is essentially just the passage of some potassium ions from one side of a membrane to the other side of a membrane. That's what happens when neurons do stuff, is potassium ions migrate out, then they migrate back in again. And it produces a voltage wave which passes along the neurons, and then some chemicals transfer it to the next neuron, and you get these electrical patterns. But how is that an experience? Now, people say, yes, but you have to interpret it at a different level. At the basic level, if you like the matter level, that's what it is. Potassium ions and stuff like that migrating about. And electrical voltages, one level up from that. But when you look at the pattern, you see an experience. But that's not correct, because the argument is circular. You have to be conscious already to see that. Who's looking? Another pattern of potassium ions moving about? There's nobody there. There's nobody to look. The consciousness has to exist outside the system to be able to look into it. As with the camera pointing at the mirror, a picture of itself on its system doesn't mean jack. It doesn't make it conscious. And if some part of my brain is able to monitor some other part of my brain, well, so what? That doesn't make it conscious either. It's just another tick box somewhere. So the neuroscience explanation of consciousness is completely void and meaningless and circular. So that's the first thing for which, when you think about it, we have no proper understanding of at all. How can a material thing produce a subjective experience which is not material? It's the old mind-body problem. It's suggestive of dualism, which is a bad thing in science, because it's thought for science to be science, if you like, that everything should be explainable by the actions of dumb matter and the basic laws of physics, of which there aren't many, despite the fact you spend years studying it. But consciousness doesn't fit that paradigm. And they struggle to do it. They come up with these explanations of the sort I've just described. But when you look at them, they're actually circular. They don't actually work. They're naive, actually. There's something more to the universe than what science knows at the moment, and it's quite a lot more by the looks of it. the idea of dualism is that the soul, if you like, or let's not get too mystical about it, let's say our experiencing self appears to be separate from the matter which underlies it, and yet it also appears to be generated by that matter. Because if you damage the brain, people's reported experiences of consciousness are different. They become unaware of certain things and more aware of other things. The same with taking certain drugs. It affects the way you view things, the way things are experienced, it appears. But there's no comprehension in science of how the experience is actually generated. We can see that stuff happens, but the jump from material to immaterial doesn't make any sense. So, another side of this is free will. In a world of material happenings, how is free will possible? Do we have free will? We don't even know whether we have free will or not. We think we do, or we like to think we do. Philosophers and scientists tell us that it doesn't make any sense. Everything that happens is determined by natural law. Literally everything, as far as we know. And now you can have a complex system which can feed back on itself and modulate how these laws have effects, and humans are an example, I suppose, of one such system, where we can think about what we're doing a bit and maybe change it to some little degree. But this is still happening within the laws of physics, if it's all material, if there is no dualist, non-material side to reality. And such a side makes no logical sense at all, of course. How would it operate without laws? So it's part of physical reality too, presumably. But if so, then it's determined. It happens because of what happened just before, and just before that. Now some people say, oh yes, but quantum mechanics allows for random outcomes. You know, a particle can be here or it can be there, and you never know which it's going to be until you actually make a measurement. Okay, but random is still not a free choice. It's a random choice. No choice at all, in fact. At least not by any conscious entity. Some molecule is deciding at random what it's going to do somehow. Maybe they have free will. I doubt it. I would think free will would be more complex than some fundamental particle on its own deciding to do something for no reason, which is what appears to happen. Randomness is not freedom. I don't have free will if my body randomly decides to go downstairs and get a cup of tea, and I don't want one. That's nonsense, right? So we don't know if we have free will. We have the appearance of it. Is it just an illusion? And we kid ourselves that we have free will. If that's true, then there are all sorts of consequences that flow from that, because it means that people are not responsible for their behaviour at all. And yet, for society to work, we really need to take responsibility for our actions and to hold other people responsible for their actions. Or, at the worst, when we're thinking about criminals, we need to at least protect the rest of society from them if we can't do anything else. But if there is no free will, we are in fact underneath it all not responsible for our actions at all. So it's another thing that doesn't really make any sense. We have to assume responsibility for our actions, and sometimes, okay, we realise that I couldn't help myself, I tried but I just couldn't resist. we know that we're not fully responsible for our actions, and we feel guilty when we don't manage to do our best. But the truth is that sometimes our best is actually impossible, or what we think of as our best is actually impossible, and we found it so. So even those of us who accept free will accept also that we don't have absolute free will. We have maybe 20% free will, and 80% is not really under our control. We're not conscious enough all the time of what we're doing and why we're doing it to be in proper control of our actions. And that's a good reason for the total chaos that our societies are in. Next, the universe is made of energy and matter, or it's got a lot of it anyway. But what are they? We know from Einstein that matter is another form of energy. Nobody really disputes that these days. It was once thought there were different types of things, but Einstein showed from E equals mc squared that energy and matter, E and m, are actually related. Bizarrely by the speed of light. So there you go. Squared. And this has been demonstrated in a zillion experiments now. It's clear. But what is energy? It's stuff. You look at a lightning bolt, you look at, I don't know, a warm teapot or something. Okay, it's got heat. Or a ball, you hold it up in the air and you drop it, chunk, down it goes. Some potential energy is converted into kinetic energy as it moves, and it bounces, and that energy is dissipated as heat. We know that energy is conserved, so in a system like that with the ball, if I raise it in a gravitational field, a conservative field, a gauge field, it gains potential energy, and then I let go of it. That potential energy is converted into kinetic energy as it moves, and it's converted into heat as it hits stuff, and sound, and flexion of the molecules in it, and so on. We know that energy in a closed system is conserved. It's neither created nor destroyed, except presumably at the Big Bang, at the beginning of the universe. There are mathematical workarounds for this, inflation and stuff like that. Cosmic inflation, not the financial sort, which is also something not really understood. But what is the energy? It has this property, but when you look at the scientific definition of energy, do you know what it is? It is the ability to do work. A particle can be said to have energy if it has the ability to do work. That is, the energy is a measure of its ability to do something. It can, if you like, bounce off another particle and move that particle. That's doing a bit of work, as we call it. That's all we know about it. It is the ability to do work. What it really is as a material object, nobody knows. If you look at a photon, we experience photons as light, and we draw our picture of the world from those few that we're able to see. Our minute fraction of the spectrum of all the wavelengths that are available. So it's doing work. It converts into electrical impulses in our retina, and that causes a cascade of responses in our brain. That's all very amazing. Assuming we have brains, of course. I'll come on to whether all this is an illusion. That's another problem. But how it's doing that, we don't physically know. It's not like a macro scale object like a ball, we can say that's a ball and I can throw it and it bounces and we know. But when you actually look down at the individual particles, all we have about them are, in fact, little tick boxes. A photon, it can have some quantum properties. It can have some spin, some polarization, a level of energy, a wavelength, a frequency, a velocity. These are all just numbers. It's like a little table of results, and they have a value 1 or 0 or half or whatever, or 2 on the quantum scale. And some types of particles can exist in the same spaces as other types of particles. Other types of particles can't exist in the same space as another one with the same quantum numbers. So there are some funny rules about the particles and the forces of nature, which are, it appears, just mediated by particles themselves, bosons, which are exchanged between particles, we think. So when a photon wants to bounce off some other particle, what it does, it seems to go up to it, some bosons are exchanged, and this particle goes off that way, and this particle goes off that way, with different energy levels now, each, total amount being conserved. But what are they made of? Whenever we get down to the fundamentals, all we have is a set of ticks in boxes of quantum numbers. Abstract. Totally abstract. And we don't even really know whether a photon is something which is, or any other particle, I'm just using them as an example, whether it's actually an independently existing entity or whether it's smeared out over all of existence. Because the way they're kind of thought of, all of the particles are existing in fields, like we have the gravitational field, or you might have an electrical field around something, or a magnetic field. Every particle is thought of as existing in a field which permeates the entire universe. So a photon in the photon field is like a blip, an increased photon potential of some sort in that photon field, and it travels across that field at the speed of light, obviously. But what is that field? It's the region in which photons can exist, you know. It's the space of photon properties. The Higgs field, which gives things their mass. Higgs particles are blips in the Higgs field. What is this field? It's just the region in which Higgses exist. It's the space of Higgs properties. This is all abstract and ultimately meaningless. Again, we have tick boxes for the properties of these particles, tick, tick, tick. And you can measure them, but we can never know fundamentally what they really are. They don't seem to exist in the way that we think of macro objects existing. I guess they exist in some form, but we might probably never know exactly what they are made of. I mean, protons are made of quarks. Quarks appear to be fundamental, but as far as we know they're not made of something smaller. Maybe they're made of strings. Electrons appear to be fundamental. Maybe it's a kind of a string. But what's a string? It's a loop. It's a vibration of what? We're always left at the end of the day with just some abstract numbers, mathematics, information. From the perspective of the human mind, information and mathematical rules are what really appear to be fundamental. It's like logic, it's like thoughts. Rules, abstract rules, are fundamental. This is very, very strange. Nothing material is fundamental, it appears. There is no material reality, ultimately. So it's all very strange. So we don't even know really if this universe that we see is even there. I mean, there are also theories that it may be just a big hologram, and what we're seeing is like a holographic 3D projection, and the real universe is on the edge of the expanding sphere, which is going out from the Big Bang still, because all of the 2D activity on that can be projected into 3D. And this kind of makes sense because holograms are a bit fuzzy, and the universe is a bit fuzzy when you get down to the quantum level. So it may be, and physicists are trying to do measurements to see whether the fuzziness is consistent with it being some sort of hologram. And again, there's the thoughts, is it a simulation, a computer simulation? It seems flipping real for a simulation, I have to say, but maybe the VR kit is really powerful. What would be the difference between a simulated universe and a real one if it's this realistic? I don't know. And there are things which are non-computable that you can make up in the real world, mathematical theorems and stuff. So how would a computed universe contain such things? So I'm a little bit sceptical. But it might be. There are reasons, quite good reasons, for thinking we might be a simulation. But we have to get on with it. We'll find out maybe when we die and wake up, in time for tea. We also, obviously, therefore, don't really know what the universe actually looks like. We see a 3D representation made by presumably by our brains, if such things exist. But in between me and this mug, there are trillions and trillions of particles appearing and disappearing, virtual particles, all the time. I don't see any of that. I only see the ones which become real, as it's known, which persist for more than a billionth of a second or so. But the universe itself is absolutely infused with all sorts of different types of particles appearing, disappearing, constantly throughout the thickness of space. But the rules allow us to see some reality and to operate within it. And we kind of think that our science is pretty advanced. And it isn't. There's a lot we don't know, and this whole talk is about stuff we don't know. And some of the stuff we don't know is extremely fundamental, but there are other things. There are technologies which we are not yet exploiting. If you think about modern technology, the changes that have been made over the last generation or two, let's say, since the beginning of the 20th century, with the invention of, say, the transistor, modern electronics, and all the wonders that have come from that, like YouTube, the internet, and iPhones and stuff like that, okay? Television. That's come from the exploitation of just one particle, the electron. But there are about 17 particles, something like that, in all, and antiparticles. We do use the positron a little bit in our electronics. We do use holes a little bit in our electronics, which is the absence of one of these particles. We even use some other quantum properties of them, other than their electric charge. We use spin a little bit in spintronics, just starting to get into it, but it's still the exploitation of the electron. But there are, as I say, at least 17 other particles. We could have muonics, pionics, neutronics, protonics. These are sciences, quarkonics, strange quarkonics, up quarkonics. There are presumably ways to exploit these things in future technologies that we haven't touched. What they would do, well, clearly we have no idea at the moment. Nobody's really investigated yet. But there is a whole zoo of particles, and there are probably other forces that we haven't met. There's dark matter now, which maybe has its own zoo of dark particles and stuff which we can exploit, or not. And you have the same problems as to whether these new particles can explain consciousness or not, because it still doesn't explain how a material thing becomes an immaterial experience, actually. But still, there's a vast, vast wealth of material particles and laws which have not been exploited yet, beyond the most basic levels. So think about that. And again, we don't know what the particles are actually made of. And furthermore, we don't even know what space is made of. The space in which everything seems to happen. The distance between objects. It appears to be quantum in nature. It appears to have a minimum scale, a granular scale, where everything has a value at every point in space. All these fields have a number at every point in space. What is it? How can it be? Who knows? And why is the universe we can see only 5% or so? Why is it just a small fraction of it matter, and the rest dark matter and dark energy, and what's it all doing? We don't know that yet. At least we've discovered it. That's something. How come we only see a teeny bit of the electromagnetic spectrum? What's happening with the rest? We can now probe with radio waves and radio telescopes and stuff. But there's stuff going on everywhere that we probably know nothing about. And quantum weirdness. I mean, we're all aware that quantum mechanics is weird, and you would expect it to be weird to us, because we have developed to grow up in a world of human scale things and human scale forces. So the gigantic and the minuscule probably, obviously, are beyond our ancestral experience. So it seems weird to us. But it is weird to us. And quantum mechanics can do some very, very strange things, like the two-slit experiment, whereby, this is well known, but you can send individual particles through a device with two slits in it, so you would expect it to go through one or the other. And if say they're particles of light, for example, photons, you send them through the two slits, and you would expect to get a bright band on this side and a bright band behind the other slit as the photon goes through one slit or the other at random. But instead you get an interference pattern, indicating that it's somehow going through both slits. And there are explanations about this. Shows that it's a ripple in the field, that it's parallel universes, or what, that it's operating backwards and forwards in time, that it's causing interference with itself, it's actually taking all possible paths through the system. These are kind of workarounds. They're not very good explanations. We don't know if any of them are actually true. And this can be taken to extremes. You can have a light source 1 billion light years away in space, sending out, and it's so far away that it's very faint, and the photons from it come to us on average about once a second. And now if there's an intervening galaxy in between us and, say, this distant, maybe it's a quasar, way out there, this galaxy will act like a lens, and the photons will come around this side of the galaxy and be bent by the galaxy's gravity towards us, or they'll come around that side and be bent towards us. And which side they come around is random, so you can see it's just like the two-slit experiment, except it's like 1 billion light years away or something. And you can point your telescope at it so you can see both sides of the galaxy. And you have your measuring kit there, and you will see that the photons come this side or that side at random. But you can then move your telescope so you only see one side. So you're only measuring one side. You can block off the other side if you like. And then you discover that actually all of the photons are coming over this side now. So what you've just done, how did they know 1 billion years ago when they were setting out to come around that side of the galaxy? What you've just done is influence the past. This experiment has been done, and it works. You can move it, you can unblock that side and unblock the other side, and suddenly the photons are all coming around this side instead. You've changed the past. How? Isn't it weird? We don't know if our universe is one of an infinite number of parallel universes, or if it's just infinitely huge in a single space, in which, therefore, far enough away there will be other copies of you and me doing exactly the same, and then doing everything differently. In one universe, I'm the Prime Minister. Probably in many more, I'm some down and out tramp somewhere. I don't know. In others, I'm on the planet Tralfamador, sipping a cup of Bojo juice or something. Whatever. If the universe is big enough, all these possibilities happen an infinite number of times. We don't know. We don't know if new universes are being spawned all the time, constantly, because of cosmic inflation, which is carrying on, and we're just in a condensed bubble which is going to survive for a while and fizzle out eventually. And then it'll eventually, after trillions and trillions of years, have another random Big Bang within it. This is speculation now, we don't know. We don't even know if we're the only critters in the whole universe. Certainly the only pseudo-intelligent ones, anyway, semi-intelligent ones. We don't know. We're looking, but we don't know. It's a big thing not to know. In fact, we don't know about, or at least there's a lot of controversy, let's say, about the existence of a god. How can all this exist without having been created by something or someone? Or, if not the universe, then the laws, which seem to be more fundamental. Something had to make those, surely. How could nothing, no time, no space, how could it have any laws or rules at all? You can't prove or disprove the existence of a god through science. One has to use one's brain and just come up with a judgment on it, really. And also, what type of God is it? Is it the God of the Bible or the Quran or something? Or, the Bhagavad Gita? Or are there lots of gods? What? Are there any? Does it make sense? And would such a God... Is there evidence that such a God is interested in us? And what about fairies, goblins, hobgoblins, brownies? I think there are some people who believe in some of these. Santa Claus, the Easter Bunny, Carlos Castaneda's allies. spirit guides, totem animals, angels, demons, aliens. We can't put all of these in quite the same box. I mean, I'd be prepared to bet 50p, say, that there is no Easter Bunny. Okay, maybe Santa too. And probably some of the rest, at least. But we don't definitely know, because you can't necessarily disprove some of these things. You can just look at the evidence and think, well, look, that doesn't really make any sense. And this raises the question of, how do we know anything? How can we know anything for certain? Well, we probably can't, and it all comes down to making a rough rule of thumb judgment about stuff. And on that basis, it seems to me the only tool we've got, or two tools if you like, or one tool, is reason. And reason's best tool is to use a combination of logic and science. Because the universe appears to have an independent existence from us. It doesn't just do what we want, it does what it wants. And we bounce around within it trying to survive until we die. And trying to get at least a good living out of it somehow, right? But it seems to me that the best way to find out what is real, what is truly the way things are, is to use science, despite all the things we don't know. At least it's based on observation. But science doesn't even know how science can work, because it relies on the assumption of cause and effect. I pick up a ball and I let go of it, and it falls because I've let go of it, because of gravity. And we infer the effect from the cause, because every time we do the experiment, we produce the cause, the effect happens. Okay, so we infer that the cause causes the effect. But we don't actually know why a cause causes an effect. So when this particle approaches that particle, it exchanges its bosons and they shoot off in the other directions. We know what happens. Well, we have a theory for what happens. And the quantum numbers get swapped between the particles, so they come off with different properties. But why it happens, and whether it will always happen, just because it's happened a billion times in the past, doesn't mean it's going to happen the 1,000,001st time. Where is the fundamental law of physics that says that? That is one of our assumptions. A system has to start with assumptions. So we have to assume that cause and effect is going to continue, because otherwise we can't do anything. But cause and effect is an arbitrary assumption. We've just seen it lots of times. The sun is going to rise every day because it always has. Well, we know that maybe in 300 million years or a billion years, it's going to blow up, or expand and eat the Earth, or at least roast it. We've discovered more about it now, but this cause and effect is another very fundamental thing about the universe that we don't understand. We accept it, and we work with it, we use it, in the same way as we use energy as the ability to do work. We don't know what it is, we don't know why it is. We just know that it is, and we use it. And that's the best we can get. And science is good for this because it's systematic. And it's right to use Occam's razor to to say, let's try and explain things in the most mundane way possible, rather than going for some airy-fairy magical thing which gives us no explanatory power. If we can't find an explanation, well, we can postulate magic, but it doesn't help, it doesn't actually do anything. An explanation saying that God is causing cause and effect doesn't change anything. It's no explanation. It may be true, but there's nothing we can do with it. Some people tell us we're supposed to worship this purported God. Well, maybe we are, maybe we aren't. We appear to be free to make up our own minds on that. Kierkegaard said that we should probably believe, because if we don't, we're in trouble. Well, maybe that's believing for the wrong reasons. Selfishness. It's not good enough. Sorry. It's all totally mysterious. But we know that some things happen which are outside science, like consciousness. That's pretty fundamental. As I say, totally unexplained. Cause and effect. Totally unexplained. Some people have psychic experiences. Largely delusion, probably, but not necessarily always. UFOs, the same, probably. But we can't prove it. I've had my own weird experiences, and there's something going on that is unexplained. Well, we just have to make the best of it. And I hope that's given you food for thought. Have you had unexplained experiences? Or do you think science is a hopeless task? Are there other things that we absolutely don't know that I haven't mentioned? Or do you disagree that we think we do know some of the things I've said we don't know? Leave your comments below, and like and subscribe, of course. Okay, bye for now.